Welcome to this IB Maths Intense video. The topic area is number and algebra, and we're going to be looking at the first part of counting principles, which is learning the essentials of factorial notation. This is a topic that's important both for standard level and higher level. See the links down in the bottom of the screen. Where does this lead us? Well, with factorial notation, this leads us into the work we're going to do on permutations and combinations, which is essential knowledge for the work later in the course on probability and on the binomial expansion, which requires knowledge of handling factorial notation. So what is factorial notation? Well, it's just very nice maths shorthand for multiplying a sequence of numbers in a descending order. You'll see it on the calculator with a little exclamation mark, X exclamation mark, and it's just shorthand. 5 factorial is just shorthand for 5 times 4 times 3 times 2 times 1, which is 120 last time I looked. And 6 factorial, no surprises, is just going to be 6 times 5 times 4 times 3 times 2 times 1, which is 720. Your calculator will do this work for you, but it's very important that you know what underlies the calculator's work. Interesting thing there, that if you look at 6 factorial, it's 6 times, and then this sequence, 5 times 4 times 3 times 2 times 1, which is actually 5 factorial if you look above. So we could also have written 6 factorial as 6 times 5 factorial. That's going to be useful later on if we want to try and manipulate expressions with factorials in them. You'll also notice that it could have been written as, if I'd have taken this bit, 6 times 5 times 4 factorial. And miraculously, they'll all give the same result of 720 if you work them out on your calculator. Notice that the x that we're using here has to be a positive integer. If I was to put the number minus 5 and then factorial into the calculator, well, I'd get a maths error. And if I tried a fraction, for example, a half to the factorial, that would also give me a maths error. One special result just to be aware of is 0 factorial is equal to 1. Kind of in the same way that any number to the power of 0 is also 1. Special result, make sure you are aware of that. So let's try and work with what we've just learnt. We now can potentially simplify factorials without using a calculator. So on your non-calculator paper, if you were to be given 6 factorial divided by 5 factorial, for example, we should be able to simplify that now, because we know that 6 factorial is actually 6 times 5 factorial, and 5 factorial on the bottom. And when we've got an expression with 2 factorials, we choose the smaller of the two as the common factor. 5 factorial is a common factor, and we rewrite 6 factorial in terms of 5 factorial. 6 factorial is 6 times 5 factorial, and then we can cancel down, and that just gives us a nice simple result of 6. So another example, 7 factorial over 5 factorial. This time they've both got 5 factorial in common, so 5 factorial stays on the bottom, but 7 factorial is 7 times 6 times, 5 factorial. So we can cancel that down again, and this time we end up with 7 times 6, which is 42 as our solution. Another simple example, 3 factorial divided by 5 factorial. Smaller of the two is 3 factorial, that will be our common factor, and we can rewrite 5 factorial as 5 times 4 times 3 factorial. And those can be cancelled down to give us a result of 1 over 20. And we can keep doing that however complicated the numbers are. So I might end up with, 8 factorial times 4 factorial over 7 factorial times 5 factorial. Again, just looking at the numbers, I see 8 and 7 factorial are close together, so I'm going to write 8 factorial as 8 times 7 factorial, and I'm going to leave the 7 factorial on the bottom as a factor, and then 4 factorial and 5 factorial, well, let's leave 4 factorial up there, and rewrite 5 factorial as 5 times 4 factorial. That enables us to pick out 2 common factors there. 7 factorial can go, 4 factorial can go, leaving us with 8 over 5. Remarkably simple, and much better to do it that way without a calculator than to multiply everything out together and end up with quite a tricky piece of arithmetic to do with the numbers. Now, what comes next? Well, we might want to show factorials algebraically, this time not showing new numbers but showing them algebraically. So n factorial follows the same idea as 5 factorial. It's just going to be n times 1 less than n, which is n minus 1, times 1 less than that, which is n minus 2, 1 less than that, n minus 3. But of course we don't know where this finishes because it could be any value for n. We just know that it will end up with 1. Similarly, n minus 1 factorial is going to start with n minus 1, and it's going to be multiplied by 1 less than that, n minus 2, and then 1 less than that, and so on until it gets to 1. But take a look at those two. Rather like 5 factorial was the same as 5 times 4 factorial, you can see that n factorial and n minus 1 factorial share a common factor there, n minus 1 factorial. So we could rewrite n factorial as n times n minus 1 factorial. That could be very useful if we're trying to factorize or if we're trying to simplify using algebra. And n plus 1 factorial, we could write that a number of ways. Of course, it's n plus 1 times n minus 1 times n minus 2, going down by 1 every time, n minus 3, so on. But looking at the patterns from above, you can see that that's the same as n plus 1 times n factorial, because if you look at this bit, this is n factorial. But we could also rewrite it as n plus 1 times n minus 1 factorial, because there's my n minus 1 factorial, and that appears also in this expression. So that's also useful. A number of different ways, factorizing it or splitting it into factors to enable us to simplify later. So here's an example of a question that would expect us to do that. n plus 1 factorial over n factorial. Choose the smaller of the two to be your common factor. So on the bottom, n factorial is smaller, so I'm going to leave that the same. And on the top, I'm going to rewrite n plus 1 factorial in terms of n factorial. Well, n plus 1 factorial is n plus 1 times n minus 1. In other words, it's n plus 1 times n factorial. And that enables us to simplify and get a result of n plus 1. That's nice and easy. And here's another example. So again, looking at the two parts of this expression, which is the smaller, n plus 1 factorial. So that's going to stay as my common factor. And now I'm going to rewrite n plus 2 factorial. Well, this is going to be n plus 2 times, well, it's n plus 1 times n times, well, that is n plus 1 factorial. So I can rewrite it like that, simplify, and get my result of n plus 2. Fantastic. Easy peasy, huh? I might be asked to actually solve an algebraic expression that has factorial. So here's an example. N factorial over n minus 2 factorial times 2 factorial equals 10. But no need to panic. Notice it says here that n must be a positive integer and is a member of the set of numbers which are positive integers. So that will limit our answer if there's more than one. What I'm going to do here again is look at the two factorials. The one on the bottom is smaller, n minus 2 factorial. So I'll leave that the same. 2 factorial. We can work that out in our heads in a minute. And I'm going to rewrite n factorial as n times n minus 1 and then times n minus 2 factorial. And of course that equals 10. Then I can cancel the expression down and I end up with n times n minus 1 over, I can do 2 factorial in my head, 2 times 1, that's 2, equals 10, which gives me a nice algebraic expression, n times n minus 1 equals 20. If I expand that out, n squared minus n equals 20. Bring everything over to the same side, n squared minus n minus 20 equals 0. And then a little bit of factorising from our prior knowledge, hopefully, of quadratics enables us to say n minus 5 times n plus 4 equals 0. And that gives me two solutions for n. That means n equals 5 or negative 4. But going back to here, where it said n must be a positive integer, that means the solution must be n equals 5. Here's another one to solve. It looks more complicated because we've got n minus 1 factorial, n factorial, and n plus 1 factorial. But again, like before, what's the smallest of the 3 factorials here that we can use as a common factor? Well, it's n minus 1 factorial. So I'm going to rewrite the expression in terms of n minus 1 factorial. And hopefully you'll remember that n factorial can be written as n times n minus 1 factorial. Brilliant. And n plus 1 factorial can be written as n plus 1 times n minus 1 factorial. Now I can divide everything by n minus 1 factorial to get rid of that part of the expression. So I end up with 40 equals 5n plus n times n plus 1. And if I expand all of that out, 40 equals 5n plus n squared plus n. So rearranging that, n squared plus 6n, and then take the 40 to the other side, minus 40 equals 0. Now again, a bit of factorising. You use the quadratic formula if you can't remember how to do that. But we end up with, in brackets, n plus 10 times n minus 4 equals 0. And so I have two possible answers for n solutions here. N equals minus 10 or 4. But because we were told n must be a positive integer, my solution must be n equals 4. So there's a number of different varieties of questions. So go for it. How about you have a go at doing these example questions, which are typical of the sorts you might find in your textbook or potentially in an exam. Have a go, pause the video, have a go at those, and then over the next slide I will go through the solutions to those questions. So the first one, just working with the same method as before. Let's factorize this expression using the smaller numbers. So 10 factorial over 8 factorial. Let's write that as 8 factorial on the bottom, but 10 times 9 times 8 factorial on the top. And then 5 factorial and 6 factorial. Let's leave 5 factorial where it is and rewrite 6 factorial as 6 times 5 factorial. And I can cancel some of this down and I end up with 90 over 6, which is equal to 15. Bit of cancelling down in your head. Hopefully 90 divided by 6 is 15. Second example that I gave you was just simplifying this expression. Now, again, we want to rewrite everything in here in terms of the smaller of the factorial expressions, which here we've got to choose between n plus 1 or n, so we'll go with n. So I'm going to rewrite the top as n plus 1 times n factorial. The bottom is n factorial plus n factorial times n plus 1, like the bit above. Now I can do a bit of factorizing on the bottom because both bits of the bottom expression have got n factorial in them. So rewriting the top, I'm just changing the order here to make it a little bit simpler to see. On the bottom, n factorial, and in the brackets I've got 1 plus, and then n plus 1. I've factorized that, hopefully you can see that. N factorial plus n factorial times n plus 1. Take n factorial outside the brackets, and inside the brackets 1 plus n plus 1. Then I can simplify that by cancelling down the n factorials, and I end up with n plus 1 on the top, and 1 plus n plus 1 is n plus 2 on the bottom. Marvellous. And then the third question, solving this time, rather like questions we did before, looking for a positive integer result. I've got n factorial on the top and n minus 2 factorial on the bottom. So let's rewrite this expression in terms of n minus 2 factorial. So I'm going to have n times n minus 1 times n minus 2 factorial on the top, n minus 2 factorial times 2 factorial, all equal to 66. I can cancel down my n minus 2 factorials and end up with n times n minus 1. 2 factorial is 2. Let's multiply out and make that 132 over there. And then I've got a nice quadratic, n squared minus n. Bring the 132 over. Minus 132 equals 0. And let's see if I can find the factors. That looks like n minus 12 times n plus 11. Again, if you don't see those numbers, use the quadratic formula to find your solutions. And we end up with n equals 12 or negative 11. But of course, the question asked us for a positive integer result, so that means n must equal 12. There we go. So there's a number of different flavors of questions, and you can see from that why it's important that you can manipulate factorial expressions to be able to simplify and solve. It's not just about being able to press the button on your calculator with the exclamation mark. So I hope you found that useful. Practice, practice, practice. Do some more examples from the books that you've got, or make up your own questions, and hopefully that will all stick. Thank you for watching this video. Don't forget to like it. Don't forget to subscribe to the YouTube channel, IB Maths Intense. Tell your friends I'm here, and there's my email address if you've got any questions or further requests.